Lesson 1, Resistance. Section 1.4, Ohm's Law, and Kirchhoff's voltage law. The relationship between the voltage V and the current I of a resistor R is known as Ohm's law. Ohm's law states that V equals Ri. Ohm's law is an important tool. We need two more laws to find voltages and currents in a circuit. One is Kirchhoff's voltage law, and the other is Kirchhoff's current law. Let's study the voltage law first. This is an example of an electric circuit. There is a DC voltage source and three resistors. The voltage source is labeled as V. The resistors are labeled as R1, R2, and R3. The voltage of the voltage source is also denoted by V. V can represent both the voltage source and its value. R1, R2, and R3 can denote both the resistors and their resistance values. The voltages across R1, R2, and R3 are V1, V2, and V2 respectively. V1 and V2 only denote the voltage values. These symbols do not represent voltage sources. A node is a point where two or more circuit elements meet. At the top left node, labeled A, the voltage source V and the resistor R1 meet. At node B, the resistors R1, R2, and R3 meet. There is one more node, labeled C, in this circuit. A loop starts at a node, for example, node A, traces the circuit elements, and returns to the same node without passing through any other node more than once. Let's call the loop in this figure loop 1. In this circuit, the polarity of the source voltage is in the same direction as the loop. Therefore, the polarity of V is considered positive. The polarities of the voltages V1 and V2 are opposite to the loop direction. In these cases, V1 and V2 are considered negative. Kirchhoff's voltage law states that for any loop in a circuit, the algebraic sum of the voltages is 0. In this circuit, V minus V1 minus V2 equals 0. This is another loop, labeled as loop 2. The voltage across R2 is in the same direction as that of loop 2. V2 is positive. The polarity of the voltage across R3 is opposite to the direction of loop 2, and V2, in this case, is negative. The voltages along loop 2 also coincide with Kirchhoff's voltage law. Experiment 1.4.1. Construct this circuit. Set the signal generator of the ADALM2000 to generate a DC voltage of V equals 5 volts. Measure the voltages V, V1, and V2 using a voltmeter. Write the relationship among V, V1, and V2 using Kirchhoff's voltage law. Confirm that the measured results comply with Kirchhoff's voltage law. Experimental setup. This is the overall experimental setup. It includes a PC, a breadboard, and a USB measurement instrument, the ADALM2000. An experimental circuit is constructed on the breadboard. ADALM2000 is connected to the circuit using jumper wires. The PC and the ADALM2000 communicate via a USB cable. A software for the USB instrument, which includes functions such as an oscilloscope, spectrum analyzer, signal generator, and so on, is available on the web page, and has been installed on the PC. This photo shows that oscilloscope running on the PC. Circuit construction. This is the appearance of the ADALM2000. It has a USB connector and input-output pins. The details of this USB measurement instrument are available at this URL. This diagram shows the pinout of the input and output pins. Use the signal generator of the ADALM2000. One of its output pins is the W1 pin, labeled as analog output 1. The G pin is the ground pin. Connect the experimental circuit, which consists of R1 and R2, to the W1 and G pins as shown in this figure. Use a breadboard to construct the experimental circuit. A shows its appearance. B shows the hole connections inside the board. The squares represent holes. Electrical leads of electric components can be inserted into these holes. The holes along the same black line are connected inside the board. Insert the resistors into the board and connect them to the signal generator. This is a photo of the resistor circuit. This is a photo showing the connections between the resistors and the ADALM2000. PC software installation. Visit the URL for the ADALM2000 Quick Start. Install the drivers and the software called Scopy, by following the instructions on the web pages. By using the signal generator of the ADALM2000 and Scopy, a constant voltage V can be supplied from the W1 pin to the circuit. Voltmeter. This is the appearance of a multimeter. This is a schematic drawing of the multimeter. This meter can measure DC voltage, AC voltage, DC current, and resistance. Switch the DC voltmeter to the 20 volts range, then the measurement range will be from 0 to 20 volts. To measure V1, simply touch the probes across the electrical leads of R1. Now the results of experiment. These were the readings on the voltmeter. The numbers were rounded to the third decimal place inside the voltmeter. The Kirchhoff's voltage law states that V minus V1 minus V2 equals 0. The algebraic sum of the measured values was 0.01 volts. The results almost satisfied this law. Exercise 1.4.1. These were the voltmeter readings in experiment 1.4.1. The results showed that V1 was not equal to V2, even though the nominal values of resistances were equal. This indicates that the actual resistances were not equal. Find the ratio of actual resistances, R1 over R2. The answer to exercise 1.4.1. Let's assume that the current I flows through the resistors R1 and R2. According to Ohm's law, V1 equals R1I, and V2 equals R2I. Thus, the ratio R1 over R2 is equal to V1 over V2, and it is calculated as 1.01. The number is rounded to the third decimal place, because the readings of voltmeter were rounded to the third decimal place. Experiment 1.4.2. Construct this circuit. Measure the voltages V, V1, V2, V3, and V4 using the voltmeter. Write the voltage relationships for loop 1 and loop 2. Confirm that the results comply with Kirchhoff's voltage law. The answers and results of experiment 1.4.2. According to Kirchhoff's voltage law, along loop 1, V minus V1 minus V2 equals 0. Similarly, along loop 2, V2 minus V3 minus V4 equals 0. These were the readings on the voltmeter, and the results satisfied Kirchhoff's voltage law. The readings of V2, V3, and V4 also coincided with Kirchhoff's voltage law. Exercise 1.4.2. This is your homework. These were the readings on the voltmeter in experiment 1.4.2. Find the ratios of R1 over R234, and R3 over R4, where R234 is the combined resistance of R2, R3, and R4. The figure at the bottom right shows an image of the combined resistance. The author of this material is Takeshi FURUHASHI, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.